Good day, everyone. We are the group 3. We were going to tackle the lesson 7 that is all about the environmental geology and earth resources. For the learning outcomes, we were going to describe the layers of the earth, explain how tectonic processes reshape the earth, report about the rock cycle by describing how igneous rocks, metamorphic rocks, and sedimentary rocks are formed. We were going to differentiate between mechanical weathering and chemical weathering. For the last one is to identify the metal and the non-metal resources.
First, we will be discussing the earth processes shape our resources. The convection in a metal causes tectonic plate movement, earthquakes, and volcanoes. When oceanic and continental plates collide, the lighter continental plates rise up, forming mountains. The oceanic plate subsides, forming trenches. The volcanic ring of fire results from this plate collision. All of us benefit from the Earth's geological resources. Right now, you are undoubtedly using products made from these resources. Plastics of many types are made from petroleum, iron, copper, and aluminum mines. Produced materials for the electrical wiring that brings you power. Rare earth metals are essential in your cell phone and your computer. All of us also share responsibilities for the environmental and social devastation that often results for mining, drilling, and processing materials. Three geological processes that have shaped the Earth include plate tectonics, erosion, and deposition, and volcanic activity. Plate tectonics describe the movements and interactions of the Earth crustals. Interaction of the Earth crustals plates, which can lead to the formation of mountains, valleys, and earthquakes. The movement of these tectonic plates is likely caused by convection currents in the molten rocks in the earth mantle below the crust. Earthquakes and volcanoes are short-term results of the tectonic movements. The long-term results of plates tectonic is the movement of entire continents over millions of years. As convection, current move the plates As convection current move the plates, stress builds up along the plate's boundaries, which this stress is released. It causes the ground to shake, resulting in earthquake. The majority of earthquakes occur along plate boundaries, such as Pacific Ring of Fire, where several tectonic plates meet. Next, we'll be discussing the Earth dynamic planet. The Earth is layered sphere. We have the core, or interior. The core is composed of dense, intensely hot mass of metal, mostly iron, thousands of kilometers in diameter, solid in the center, but fluid in the outer core. The immense mass generates the magnetic fields that envelops the Earth. The Earth core is the very hot, very dense center of our planet. The bowl-shaped core lies beneath the cold brittle crust and mostly solid mantle. We have also the mantle. Surrounding the molten outer core is hot, pliable layer of rock is called mantle. The mantle is much less dense than core because it contains a high concentration of lighter elements such as oxygen, silicon, and magnesium. The mantle is the mostly solid bulk of Earth's interior. The mantle lies between Earth's dense, superheated core and its thin outer layer, the crust. The mantle is about 2,900 kilometers or 1,802 miles thick and makes up a whopping 84% of Earth's total volume.
Earth is a dynamic planet. The outermost layer of the Earth is cool, lightweight, brittle rock is what we call the crust. The crust below ocean is relatively thin, of 8 to 15 km, dense, and young, less than 200 million years old, because of constant recycling. The crust under continents is relatively thick, and it has 25 to 75 km and light, and as old as 3.8 billion years, with new material being added continually. It is also a predominantly granitic, where areas oceanic crust is mainly dense basaltic rock. So ang crust niya below sa ocean, it has na siya nga ginanipison og 8 to 15 km dense. And the crust below the ocean is young and it has less than 200 million years old. It is because of the constant recycling. While on the other hand, the crust that under in the continents has a thick of 25 to 75 km and light, and it is old as 3.8 billion years. So while the crust of the ocean is young and has less than 200 million years old, lahi ra pod ang naa sa crust nga naa sa continents, which is old and it has 3.8 billion years. It has a new material being added continually. The under of the cross continents has a predominantly granite, while the areas of the oceanic crust has mainly dense of basaltic rock. And we go to the tectonic processes reshape continents and cause of earthquakes. The huge convection currents in the mantle are thought to break the overlying crust into a mosaic of huge blocks which we call the tectonic plates. These plates slide slowly across the Earth's surface like wind-driven ice floes on water, in some places breaking up into smaller pieces, in other places crushing under ponderously into each other to create new, larger and land masses. The ocean basins form where continents spread and pull apart. So the tectonic plates has a different types of movement, which are the convergent, divergent, and the transform. While the tectonic plates is crushing ponderously into each other, so the tectonic plates can create a new and larger land masses. Magma, or the molten rock, it is forced up through the cracks forms new oceanic crust that piles up underwater in mid-ocean ridges. So we know that the magma is a mixture of molten and semi-molten rock which is found beneath the Earth's surface of the Earth. So creating the largest mountain range in the world, these ridges wind around the Earth of 74,000 km, or it has a 46,000 millimeter. Although concealed from our view, this jagged range boasts higher peaks, deeper canyons, and sheer cliffs than any continental mountains. Slowly spreading from these fracture zones, ocean plates push against continental plates.
Tectonic processes reshape continents and cause earthquakes. Earthquakes are caused by jerking as two plates grind past each other. This is the example of earthquake that caused by jerking as two plates move each other. Mountain ranges like those on the west coast of North and South America are pushed up at the margin of colliding continental plates. The Himalayas are still rising as the Indian subcontinent collides inexorably with Asia. Southern California is sailing very slowly north toward Alaska. In about 30 million years, Los Angeles will pass San Francisco if both still exist by then. This is the map of tectonic plates. Plates boundaries are dynamic zone characterized by earthquakes, volcanism, and the formation of the Great Rifts and mountain range. Arrow indicates of subduction whereon plates is diving beneath another. These zones are site of deep trenches in the ocean floor and high levels of seismic and volcanic activity. Tectonic processes reshape continent and cause earthquake. When an ocean plate collides with a continental landmass, the continental plate usually rises up over the seafloor, while the oceanic plate is subducted or pushed down into the mantle, where it melts and rises back to the surface as magma. So this is the example of continental plates over the seafloor. Deep ocean trenches mark this subduction zone and volcanoes from where the magma erupts through vents and fissures of the overlying crust. Trenches and volcanic mountain range and Pacific Oceans rims from the Indonesian to Japan to Alaska and down the west coast of Americas, forming a so-called ring fire where the oceanic plates are being subducted under the continental plates. This ring is the source of more earthquakes and volcanic activity than any other region on the earth.
So we have here the example of continental tectonics. So plate tectonics is the theory that Earth's land masses are in constant motion. Geologists prove that the movement of tectonic plates is related to the convection currents in the Earth mantle. Convection current describe the rising, spread, and sinking of gas, liquid, or molten material caused by the application of heat. So why did that the tectonic plates causes earthquake? It is because when the stress on the edge overcome the friction, there is an earthquake that releases energy in waves that travel through the Earth's crust and cause the shaking that we feel. Tectonic plate movement, where thin oceanic plates diverge, upwelling magma forms mid-ocean ridges. A chain of volcanoes, like the Hawaiian Islands, may form as plates pass over a hot spot where plates converge. Melting can cause volcanoes such as the Cascade. Over all millions of years, continents can drift long distances. Antarctica and Australia once were connected to the Africa, for instance, somewhere near the equator and supported luxuriant forests. So, what comes in your mind when we say luxuriant forest? So we have here the example of a luxuriant forest. So it characterized by dense vegetation, rich of the biodiversity, and abundant growth of trees and plants. Factors like favorable climate, nutrient-rich soil, diverse ecosystem, natural disturbances, and human management contribute to its lushness. The luxuriant forest, generally composed of tall, broad-leaved trees and usually found in wet tropical uplands and lowlands around the equator. The geologists suggest that several times in the Earth's history, most or all of the continents have gathered to form supercontinents which have broken up and reformed over hundreds of millions of years. The redistribution of continents has profound effects on the Earth's climate and may help explain the periodic mass extinction of organisms, marking the division between many major geologic periods. We humans have now become a major geological force. We may move more dirt and rock and cause more species extinction every year than any natural forces. Some geologists call this new era the Anthrop- Anthropocene after its most important driving force us. So this is the example of the Pangea, an ancient supercontinent of 200 million years ago. It combines the world's continents in a single landmass. Continents have combined and separately repeatedly. So we have here the example of for example of the era, their periods and life on Earth. So in the era of Cenozoic, we have the Quaternary and the Tertiary periods. So it is the first humans and the first important mammals. So second, we have the Mesozoic. So their periods is Cretaceous, Jurassic, and Triassic. So extinction, this is the extinction of the dinosaur, first dinosaurs. So third, we have the Paleozoic. So in their periods, we have the Permian, Mississippian, and Devonian, Silurian, the Ordovician, and the Cambrian. So the life on Earth under for this era, we have the first reptiles, the fish become abundant, first abundant fossils, and lastly we have the Precambrian. So life on Earth under for this is the earliest single-celled fossils. The Precambrian accounts for the vast majority of geologic time origin of the Earth.
Rocks. A mineral has a specific chemical composition and crystal structure. A mineral is a naturally occurring inorganic solid within a specific chemical composition and a specific internal crystal structure. A mineral is solid, therefore ice is a mineral with a distinct composition and crystal structure, but liquid water is not. Similarly, molten lava is not crystalline, although it generally hardens to create distinct minerals. Metals, such as iron, copper, aluminum, or gold, come from mineral ores, but once purified, metals are no longer crystalline and those are not minerals. The three rocks type: igneous rocks, metamorphic rocks, and sedimentary rock, constantly reform into each other. A rock is a solid, cohesive aggregate of one or more minerals. Within the rocks, individuals, mineral crystal or grains, are mixed together and held firmly in a solid mass. The grains may be large or small, depending on how the rock was formed, but each grain retains its own unique mineral qualities. Each rock type has a characteristic mixture of minerals, grain size, and ways in which the grains are mixed and held together. Granite, for example, is a mixture of quartz, feldspar, and mica crystal. Rocks are granite-like minerals contain but much finer crystals are called rhyolite. Chemically, similar rocks with large crystals are called pegmatite. pegmatite. Although rocks appear hard and permanent, they are part of a relentless cycle or formation and destruction. They are crushed, folded, melted, and recrystallized over time by dynamic processes related to those that shape the large-scale features of the Earth's crust. We call this cycle of creation, destruction, and metamorphosis the rock cycle.
The rock cycles creates and recycles rock. Although rocks appeared hard and permanent, they are part of a relentless cycle of formation and destruction. They are crushed, folded, melted, and recrystallized over time by dynamic processes related to those that shape the large-scale features of the Earth's crust. The rock cycles is the continuous process that describes how three main rock three main rock types is that igneous rock, igneous sedimentary, and the metamorphic. They are formed, transformed, and recycled over geological time. We call we call this cycle of creation, destruction, and metamorphosis the Earth cycle. Understanding something of how this cycle works helps explain the origin and characteristics of different type of rocks. There are the three different type of rocks. The igneous rock. Igneous rock are formed when molten rock or magma cools and solidifies either beneath the Earth's surface or on the surface. When the magma cools slowly underground, it is formed the intrusive igneous rock like granite. It, when magma cools quickly on the surface, it forms intrusive igneous rock like basalt. And the number two is the sedimentary rock. Sedimentary rock are formed when whether the eroded materials from other rocks are transported by water, wind, or ice, and then deposit and compress over time. It is example like the sandstone, the limestone, and the shale. The sedimentary rocks transform into a metamorphic rocks through heat and the pressure. And the last the metamorphic rock. The metamorphic rock are formed when existing rocks are subjected to high heat and pressure, causing the mineral composition and the texture of change. Can help the metamorphic rock include the slate, marble, and the gneiss. gneiss. Metamorphic rock can melt to form magma, com- magma completing to complete the cycle. The rock cycles is a continuous process driven by the internal heat of the earth as well as the external process like weathering and erosion. The rock cycles creates the recycled rock. There are the three major rock classification: the igneous, the metamorphic, and the sedimentary. Igneous rock from igni, the Latin word for fire, are solidified from hot, molten magma or lava. Most rock in the Earth's crust is igneous. Magma intruded to the surface from volcanic vents cools quickly to make finely crystalline rock such as basalt, rhyolite, rhyolite or andesite. Magma that cools slowly in subsurface chambers or in intruded between overlying layers makes firstly crystalline rocks such as gabbro, rich in iron and the silica, or a granite rich in aluminum and silica, depending on the chemical composition of the. So the igneous rock formation are formed from the solidification of molten rock material called magma. So mo ni siya, ang igneous rock is formed siya o magma or the lava that generate between the earth's crust or the mantle and the metamorphic rock. Murag sa the igneous rock.
The rock cycles, creates and recycles rock. Metamorphic rocks from the melting, contorting and reci- recrystallizing of the other rocks deep in the ground. Tectonic forces squeeze, fold, heat, and transform solid rock. Under these conditions, chemical reactions can alter both the composition and structures of the component materials. Metamorphic rocks started out as some of other type of rock but have been substantially changed from their original igneous, sedimentary, or earlier metamorphic form. Metamorphic rocks when form when the rocks are subjected to high heat, high pressure, hot mineral-rich fluids, or more commonly some combination of the factors. Metamorphic rocks are classified by their chemical composition and by the degree of some minerals form only under extreme pressure and heat. Diamonds or jade, for example, other form under more moderate conditions. Some common metamorphic rocks are marble from limestone, quartzite from sandstone, and slate from mudstone or and shale. In metamorphic rocks, some or all of the minerals in the original rock are replaced atom by atom to form new minerals. Type of metamorphic rocks include quartzite, marble, soapstone, and pyrite. Sedimentary rocks. Sedimentary rocks are formed when grains of other rocks and consolidated by time and pressure. Sandstone, for example, is solidified from layers of sand, and mudstone consists of extremely hardened mud and clay. Tuff is formed from volcanic ash, and conglomerates are sand and gravel. Sedimentary rocks are formed from deposits of pre-existing rocks and or pieces of once living organism that accumulate on Earth's surface. Example: limestone, shale, chert, chalk, and claystone. Rock salt, made of mineral, is ground up to produce original table salt, sodium chloride, salt deposits crystal behind limestone is a rock composed of cemented remain or marine organism. You can often see the shape of shells and corals in a piece of limestone.
So this is the different colors of soft sedimentary rocks deposited in ancient seas during the Tertiary period in 63 to 40 million years ago have been carved by erosion into the fluted spires and hoods of the pink cliffs of Bryce Canyon National Park. The weathering and sedimentation. Most crystalline rocks are extremely hard and durable, but exposure to air, water, changing temperatures, and reactive chemical agents slowly breaks them down in a process called weathering. The mechanical weathering is a physical breakup of rocks into smaller particles without a change in chemical composition of the constituent minerals. You have probably seen the results of mechanical weathering in eroded rocks in rivers or and shorelines, smoothed by constant tumbling in waves or currents. On a larger scale, mountain valleys are carved by the rivers and glaciers. So this image is an example of the weathering that slowly reduces an igneous rock to loose sediments. That is an exposure of moisture expands minerals in the rock, and frost may also force the rock apart. The chemical weathering. So what is chemical weathering? The chemical weathering is the selective removal of alteration of specific minerals in rocks. This alteration leads to weakening and disintegration of rock. Among the more important chemical weathering process are oxidation combination of oxygen with an element to form an oxide or hydroxide mineral, and hydrolysis or the hydrogen atoms from water to molecules combine with other chemicals to form the acids. The product of these reactions are more susceptible to both mechanical weathering and dissolving in water. For instance, when carbonic acid are formed when rainwater absorbs the CO2, percolates through porous limestones layers in the ground, it dissolves the rock.
Good morning, classmates. Good morning, teachers. My topic is all about weathering and sedimentation. Particles of rock loosened by wind, water, ice, and other weathering forces are carried downwind or downstream until they come rest again in a new location. Deposition of this material is called sedimentation. Water, wind, and glaciers deposit particles of sand, clay, and salt far from their source. Much of the American Midwest, for instance, is covered with hundreds of meters of sedimentary materials by the glacier, till or rock debris deposited by glacial ice. Wind, loose, or of the dust deposit, river deposit of sand and gravel, and ocean deposit of sand, salt, clay, and limestone. The earth is unusually rich in mineral variety. Mineralogists have identified some 4,400 different mineral species. Far more, we believe, than any of our neighboring planets. What makes the difference? The process of plate tectonics and the rock cycle on this planet have gradually concentrated uncommon elements and allowed them to crystallize into new minerals. But this accounts for only about one-third of our geologic legacy. The biggest difference is light. Most of our minerals are oxides, but there was little free oxygen in the atmosphere until it was released by photosynthetic organisms, thus triggering evolution for a great variety of minerals. Economic mineralogy is the study of resources that are valuable for manufacturing and trade. Most economic minerals are metal ores, minerals with unusually high concentrations of metals. Lead, for example, generally comes from the mineral galena, Pbs, and copper comes from salt ores, such as bornite, CuSFeS4. Non-metallic geologic resources include graphite, feldspar, quartz crystals, diamonds, and other crystals that are valued for their usefulness or beauty. Sedimentation is the deposition of rock fragments, soil, organic matter, or dissolved minerals. And in American Midwest, more sedimentary materials left by glaciers, which makes a big problem of American because adult particles sometimes weigh us to thousands of tons. Economic mineralogy is the study of resources that is valuable for manufacturing and trade. Our earth has lot of minerals. If we will not take good care of it, we will be the one to suffer. Like mining, many people died because they just continue mining, but they did not think about floods. They did not know how important trees in our life and in our ecosystem. That's all. Thank you.
Metals have been so important in human affairs that major epochs of human history are commonly known by their dominant materials and the technology involved in using those materials like Stone Age, Bronze Age, Iron Age, etc. The mining, processing, and distribution of these materials have broad implications for both our culture and our environment. Most economically valuable crystal resources exist everywhere in small amounts. The important thing is to find them concentrated in economically recoverable levels. So, throughout history, metals have played a crucial role, shaping major epochs like the Stone Age, Bronze Age, and Iron Age. The mining, processing, and distribution of metals impact both culture and the environment. Valuable metal resources are present globally, but the key is finding them in economically viable concentrations. Earth's resources, including oil, gas, and coal, are the foundation of our economy. Metals are expensive to extract, but they are extremely valuable because they are ductile and bendable, yet strong and because they carry electricity. Example, copper. Mining and refining of metals and other geologic resources can cause severe environmental damage. In some cases, land can be restored to something close to its original state, but, but when you dig a mile deep hole in the ground or look the whole top of a mountain and dump the waste into a nearby valley, it's unlikely that the damage will ever be undone. So, Earth's resources like oil, gas, and coal drive our economy. Metals, despite being costly to extract, are prized for their ductility, strength, and conductivity, as seen with copper. However, mining and refining processes inflict significant environmental harm. While land can sometimes be restored, extensive actions like digging deep holes or removing mountaintops often cause irreversible damage. Table 12.2 Primary uses of some major metals. First is aluminum. Packaging foods and beverage 38%, transportation, electronics. Next is chromium. High strength steel alloys. Next is copper. Building construction, electronic industries. Next is iron. Heavy machinery, steel production. Next is lead. Leaded gasoline, car batteries, paints, and ammunition. Next is manganese. High strength, heat resistant steel alloys. Next is nickel. Chemical industry steel alloys. Next is platinum group. Automobile catalytic converters, electronics medical uses. Next is gold. Medical, aerospace, electronic uses, accumulation as monetary standard. Last is silver. Photography, electronics, jewelry.
Non-metal mineral resources include gravel, clay, glass, and salt. Non-metal mineral constitute a broad class that cover resources from gemstone to sand, gravel, salt, limestone, and soils. Sand and gravel production for road and building construction comprise by the far the greatest value and dollar value of all non-metal mineral resources and a far greater volume than all metal ores. Sand and gravel are used mainly in brick and concrete construction, in paving as loose road pillar, and for high purity silica sand is our source of glass. These materials usually are retrieved from surface pits mine. Limestone, like as sand and gravel, is mined and acquired from concrete and crushed for road rock. It's also is cut for building stone, pulverized for use as an agricultural soil additive that neutralize acidic soil, and roasted in the lime kilns and ferment plants to make plaster, hydrated lime and cement. Evaporate materials deposited by evaporation of chemical solutions are mined for highlight, gypsum, and phosphorus. These are often found at or above 97% purity. Alite or rock salt is used for water softening and ice skating on winter roads in some northern areas. When refined, it, it is a source of table salt. Gypsum, calcium sulfate. Now, now make your plaster well board, but has been used to cover walls ever since the Egyptian plastered their frescoed tombs along the Nile River some 5,000 years ago. Potash is a evaporate composed of a variety of potassium chloride and potassium sulfate. This highly soluble potassium salt have long been used as soil fertilizer. Sulfur deposits are mined mainly for sulfuric acid production. In the United States, sulfuric acid use amount to more than 200 lb per person per year, mostly because of its use in industry car batteries.
Non-metal mineral resources include gravel, clay, glass, and salt. Interestingly, the world's largest supply of lithium, which is essential for lightweight batteries for electric cars, cell phones, and other consumer goods, is a vast salt flat called the Salar de Uyuni in southwestern Bolivia. The lithium, which was deposited when a huge salt lake evaporated eons ago, could make this impoverished country the Saudi Arabia of the electronic age. Currently, the Earth provides almost our fuel. At present, modern society functions largely on energy produced from geologic deposits of oil, coal, and natural gas. Nuclear energy, which runs on uranium, provides about 20% of our electricity. Renewable sources such as sun, wind, hydropower, biomes, and geothermal energy could replace all the fossil fuel and nuclear power we now use while reducing pollution and reducing global climate change.
Currently, the Earth provides almost all our fuels. Oil, coals, and gas are organic, created over millions of years as extreme heat and pressure transform the remains of ancient organisms. They are not materials because they have no crystalline structure, but they can be considered part of economic mineralogy because they are such important geologic resources. In addition to providing energy, oil is the source of material for plastics, and natural gases is used to make agricultural fertilizers.
So, in conclusion, the Earth's surface is shaped by shifting pieces of crust, which split and collide slowly but continuously. Earthquakes, volcanoes, and mountains generally occur on the plate margins. Rocks are composed of minerals, and rocks can be described accordingly to their origins in molten materials or indigenous rocks. Eroded or deposited sediments or sedimentary rocks or materials transformed by heat and pressure deep in earth or metamorphic rocks. Resources, including oil, gas, and coal, are the foundation of our economy. Metals are expensive to extract, but they are extremely valuable because they are ductile yet strong and because they carry electricity. Mining and refining of metals and other geologic resources can cause severe environmental damage. In some cases, land can be restored to something close to its original state, but when you dig a mile deep hole in the ground or lop the whole top of a mountain and dump the waste into a nearby valley, it's unlikely that the damage will ever be undone.
Conclusion. Many materials can be recycled, saving money, energy, and environmental quality. Recycling aluminum consumes 1/20 of the energy to extract new aluminum. For example, the recycling copper takes about 1/8 as much energy. We can also save energy and resources by replacing traditional materials, materials with newer or more efficient ones. Fiber optic communication lines have replaced much of our copper wiring, adding speed and efficiency while saving copper use. Understanding both geology, hazards, and resource is essential in environmental science. These factors influence environmental quality research provisions. And recycling saves energy and resources. So the recycling materials like aluminum and copper requires less energy to compare the extracting processes from new raw materials. For the recycled copper takes about 1/8 the energy of extracting new copper. And the aluminum, it takes 1/20 of energy producing new aluminum for the raw materials. In traditional materials with efficient alternatives, so it examples the fiber optic that communication lines replacing much of the traditional copper wiring. And the fiber optic technology is more efficient and faster than the copper wiring. And I demonstrate how advancement in materials technology can lead to more efficient to use use of resources. And the importance of the understanding geologic factors. We both geological hazards and the resources essential to our environment science. And the geologic factors influence our environmental quality, resource availability, and the sustainability. It is knowledge to crucial for making informed decisions about resources to use, the recycling materials, and, and to protect our environmental. By recycling and adapting more efficient materials of and technologies can significantly reduce energy consumption and depletion. Thank you.